It was a few years ago that at the University of Delft there was a professor with sustainability in his agenda, and he said, he had a bold statement: we want to be climate neutral by 2030. He said that in 2022, and that's quite a bold statement because the large agenda is about 2040 for the Netherlands, and I think for Britain as well. And there are many things on that agenda, but I ask myself, what does it mean for AV? Because we have a lot of devices overall and all closets everywhere. And what does it mean for our stuff? And if you think about, for instance, a projector, it's quite a complex thing. You have coolant in it, you have optics in it, you have plastics in it, metals, etc., etc. And it all has their relationship to the climate. Some pollutions, etc., etc. So where to start? And if you know, if you read some things online, then you know the social development goals of the United Nations. And if you go to number 12, it's the responsible consumption and production, and that fits with our equipment on campus. And if that is not enough, I was walking somewhere in Belfast and saw this very nice art, and this is our footprint, and it was really shocking, and we took that with us. So what can we do as higher education community to fill that in? We have help from students of our scientific technical university, and they did a very nice work to visualize the life cycle of equipment from out of a university perspective. And this is quite a nice LCA, as we call it, life cycle analysis, and you see in the beginning about a quarter of the total footprint of equipment is during the manufacturing, during the fabrication, the mining of minerals, making this footprint. So if you buy equipment like the thousands and more assets of in the Oxford project of yesterday, what would be the footprint of this stuff? And we call it embodied footprint because it's in there. Manufacturers have made it, they've used energy, green energy, whatever materials. And for us, it's 1% of distribution. But for an integrator, the distribution is probably about 80% to do their work, to minimize their transports, electric cars, and all the packages, etc. And then the shocking thing came because we used it about 80% of this total lifetime. It's us, it's you and you in this room, we are that. So what can we do about that? And the last thing is disposal, and that's what we do. The next thing where a large hurdle to get is we have a normal ingrained way of replacing equipment every 5 years. We call it depreciation time, probably the same. You call it probably the same, I'm not sure in Britain. But what if you think about it, okay, we do 5 years about equipment, so the second year it's about 80%, and the third year it's about, etc., up to the fifth year at 0%. You take your budget, buy new, and the cycle goes over again. But what if you stretch this equipment? What will be the value in year 6 or year 7? That was one question, because I want to give some value in the installed base that we have over our university. But also, we had another problem. If you don't spend your budget in our input financing institutes, you lose your budget. And in the 6 years, you have a budget cut. So what can you do in year 8 or year 9 when you have to replace it? How can you cope with that? So with procurement and financial people, we still have to work that out. Okay, from this life cycle, 2 things are really already set. With our procurement, they ask and demand from the integrators that the logistics will be with these electronic cars or whatever, and that they take away all the packets and stuff, etc. And also, end of life, they take our 5-year-old equipment and put it elsewhere, or where it will end on a large heap on the landfill or whatever. We don't know. At least we get rid of it. But what about these? This is very large, and we are in charge. And everybody with, let's say, complex lecture halls, lecture capture, all the hybrid stuff, it's a huge heap of devices. And if you look into a complex system, we've got 32 categories, and just now you had it about an ontology, a classification, or some sort of devices. How can we deal with it? How can we cope with it? And if you count it all up, how large is this footprint? Well, we don't know. Perhaps you have an idea, and that's where we had to start. We need to do something, we need to make it tangible, and that's the talk of today. So how do we do that? Especially these large lines, we are all owner of these actions. We are not doing it yet, but we have to do it in the coming years. And we use that greenhouse gas protocol for it. And probably most of you know it, but this is also a way to make things visible, and scope 1 is about direct emissions. That is the electricity that your devices use directly. And you can count it up, you can measure that. Scope 2 is what you buy in, and that is, for instance, the warmth and the heating, etc., but it's out of our scope, out of AV scope, as I may call it. And scope 3 is the embodied carbon, so the products that you buy and that you get for free. I will start with this scope 3. Raw materials, what can we do? Okay. I was thinking about what can we do in the coming years, so I thought of very simple 3 plans, plan A, B, and C. Today we talk only about plan A, and that is, let us have an idea of the footprint of our stuff that we have inside. At least if you measure it, we can go a step further. You can compare it with your peers, and we can do something about it. Plan B, of course, is one step further. Once you know it, you can calculate with it, you can do something. And plan C is, if we march together with us all, we get a good feeling, and we have a good demand for the market to fill us in and to answer us about their way of production, etc. Yesterday, I asked several stands about what they call EPD, Environmental Product Declaration, the footprint of their products. I didn't get an answer, but at least it was on the agenda. People are thinking about it, so it's coming. And just to map a few things, we have these projectors. Those are the heavyweights, of course, and the large displays, large interactive displays, have a lot of electronics inside, use a lot of materials and also a lot of power. And we have a lot of significant electronics, all the devices that you do not see, but they are there in the AV rack. If you are an AV engineer, you know where to find them, and it's not about a few, it's about hundreds, even thousands. And for us it's thousands, and yesterday at the Oxford, I'm looking for the Oxford guys, but, okay. So it's a large heap of devices, and probably you know the exact footprint by now. And next to that, we have a lot of chairs and other things, and they have their own footprint. But in furniture, it's rather clear and already set in their processes. They exactly know for refurbs and other reuse of materials. It's quite far within the furniture world, but in AV it's not yet. So how do you map these things? We did not know, and just ask a consultancy bureau to help us. And that bureau, their way was counting the number of computers and getting it up and put a factor to it, and then you get some sort of idea. But AV, it was a complete unknown for them. So we put on together, and I will not tell about the struggles that we had underway, but the result for our first attempt was in 2023, and just to give you an idea of what we had, it's 3,200 tons of embodied, and we're not talking about the energy, we're talking about the embodied carbon footprint that we got for free when you buy stuff. And it's comparable, so what is it? It's comparable to 160,000 trees who get the CO2 for 1 year long. But still, it's so intangible. It's the same as 220 annual households. This is quite a lot, but can you imagine? It's still hard to make that connection, but we have to start somewhere. And the same it was for the melted polar ice, and I was asking, okay, how much meters of a glacier will disappear? So I asked a glacier scientist at our university, how do you calculate with that? And that is over here, 1 kilo of CO2 melts about 15 kilo of glacier ice. So if you were on a winter sport last year and in this way, next year you will not be on that same glacier because it's much shorter. And we are active users of that. Our next indication, because we are still counting and still not yet ready, because we have to 2030 but work every day and need to work hard if we get it right by that time. So this is our second footprint. It was the last quarter of the first quarter of this year. And it's nearly doubled, and you see the amount of AV system has quite grown if you compare it to the other things. The furniture we haven't counted more because it's about 100 extra seats for a new building, but it's about it. And computers is still the same, but with computers we are working with the asset management really for IT, and we think AV asset management is for us. So it's a bit a frozen parameter at the moment, but we will work on that in the rest of this year. So it's an ongoing, and we do not have precise and absolute figures, but this is what we have at the moment. So what can we do with this 23% of embodied carbon footprint? At first we have to realize, of course, we want to ask these EPDs, these environmental product declarations, and before we have them, let's say, let's start, just start. And what did we do? The first thing is stretch the lifespan. I heard it this morning. If you have a certain embodied footprint and you divide it over 5 years, then it's a certain amount. If you divide it over 6 years, it will become smaller. So how far can you go? And within the AV, we have equipment with nearly 20,000 operational hours. That is about it if you buy stuff in. If you compare that to 24/7 at one row, it's 2.3 years. Okay, what do we do about it? But the next thing is more important. Most of the devices and the DV, LED, etc., they have 100,000 hours of lifespan, and that's more than 10 years, I think. So we can easily stretch this 5 years up to at least 10 years for our devices. Probably not for computers, probably not for interact using materials, but for the rest of our AV stack, we can do that. So if you do that and make it a bit measurable, so we have introduced what we call the green color progress. And what you see over here is the blue bars are just the 5 years lifespan of the devices, 60 months for 5 years. And when it is at 61st month, it got a green slice on it, and it grows greener. The longer we have it in operation, the greener the top will be. So this green color is for us a very visible metric to work with it. And we can compare if you have your own list and worksheets of your own stock, and put these, we have some parameters for you, and you can do this, and you can give an insight and a feel of what your share is in this project. Why should you do that? For instance, there is only one example. We have 287 projectors with an extended month of more than 7,000, and if you divide it over and over, and we started with projectors with an average price of 80k, and let's say that we have only 50k per projector, and times this, we have spared virtual money for 1.85 million. And it is easily 3 million if we compare it to our total installed base. But this is only projectors, and we have 32 categories. So what does that mean? The money that you do not spend in this normal 5-year, let's say, exchanging cycles. We can do a lot with that. It's not only spare you money, but also make the footprint, the embodied footprint, smaller for all your installed base. I dare you to do this with your own thing, and you probably see what amount of money this is about. So that's the first thing, and what can we do about the other thing, the use phase? How can we deal with that? And that's hard. It's also hard. What would you do? We're just trying to start calculating. And if you see, okay, what is the energy that they use? Normal systems like this are operational for in term of education with about 40 hours a week during 10 weeks. It's an indication. And also the computers that are on in the morning at 7 and turned off at 11 in the evening, and the devices that are on always. So these are the hours, and if you do some more calculations and put that into real systems that you use, for us I've done it for 4 categories. We have quad signal system, AV systems, so there's a lot of devices in it, but also the dual signal, the single signal like this one, they have less distribution, etc. And the hybrid rooms, I think there are a lot of them since the pandemic, and it gives some indications about 2,000 kilowatts for the more complex halls, and about 800 kilowatts for the simple halls, and this is per 3 months, because we're working to a certain reporting, and for the reporting we use what they call performance indicators. Perhaps you know the drill for performance indicators. Every 3 months you report about it, you freeze that moment, and you go on, and in time you see some sort of trend, and you can work on that. If you do good or you do better, it helps you at least to get your fingers behind what you are doing. Of course, you know already a lot of stuff we can turn it off if we want to, if we are able to, if we have designed it in that way. And that's our let's say challenge for the coming years. You cannot change it in one day and put, let's say, the complete chain into pieces and only let the controller be on for 100% and turn the rest off. That would be the ideal situation, but that is not today. But in the future, the PDUs, the power distribution units, you can put them according to, for instance, an AVIXA standard as well. So we can do a lot, and when you do that, the energy power use is of course less, but also you can age your equipment, because if you diminish the operation hours, you can stretch the lifespan. And there's some sweet spot in the middle. Where's the break-even point? I do not know yet. We have to find it out in the coming years. And I do not even talk, but we had some challenges too, that there was a large amount of equipment in one room, and the temperature was rising. There was not a good climate situation, not a good AVAX available. And so if you know, with a higher temperature, electronics have a shorter lifespan. So there is something to gain there also. The last piece of this life cycle analysis is, of course, the disposal. What can you do? After 5 years, you can give it to the integrator, or you can do some upcycling, and most of you do this these days. But sometimes we are really dependent on, for instance, take Teams, take Windows 11. You need new hardware to do the same with new software. Why must we do that? Because the market rules us to do. And perhaps we should turn that around. We want to demand it instead of the other way around. But at least if you still have good equipment, but not functional enough anymore for what you want for features for a certain hole, you can always put it on another, in another place. And what we did, we have now around 400K of, and we call it market value, because we took out a projector, for instance. It wasn't good enough anymore for what we wanted. Take a look at the market price and sell it to a faculty or a staff group or whatever, with this remark that it is cheaper, it can be broken, so please be aware that it will not be there for 5 years, but probably it is. And they do their bit because they think, okay, this is good enough to do our bit, to do our share for this green AV movement as well. So you need some appointments, you need some agreements from that, but still you can do it. And the third thing, of course, is recycling. That is out of our hands. That you have to search a pattern for that. But what you can do, and that is what we have to do once we have our fingers behind, is some sort of plea to the market. Please give me an estimation of your product so we can calculate, so we can get a feel of it. And at the same time, we demand a right to repair, and it is even law from out of the European Union at the moment. And what I think also is we used to buy a product, but it will change into not only a product, but product with service. It will change in another way. You have repair shops. Those are more in the, let's say, amateuric way, but why not in the professional way? And, I think it will change. And also, I have a very good television of Samsung at home, but all the smart applications do not work. Why not another system on chip, put it in and stretch the lifetime of the hardware? Now we do it externally with a streaming device, but why not intentionally? We have made several applications which we use for designing classrooms and also for publishing lecture halls in an online catalog. And we put it all together now with the AV asset management. So it's one package, and I just want to show you only a sneak preview, 1 minute of every page, just to give you an idea with what we are working. I'm already logged in, you haven't seen the intro, but what we have is, this is our configurator, and if I go to a classroom, for instance this one, I just want to show you what we have done to design a classroom together with architects. But most of you have challenges with architects when you have new buildings or refurbishment, etc. What should be what I call visual acuity, readability of, if you are in the back seat, can you still read it? And if you wear glasses, you go to the optician and you want 100% visual acuity, that's quite normal. But when the AV was digitized, when we got all digital signage and screens inside our classrooms, I must admit at that time, before we did the standardization campus-wide, about 70% was not well enough. You could not see it if you had normal vision. Luckily, we have a lot of students, they have eagle eyes, so they could, We haven't had too much complaints, but still, how do you do that? So we had to work that out. I'm just doing some. If for instance the first row, if you change that, it's calculated instantly, and this is for instance for a virtual corner because you cannot go over 25 degrees before your skull hits your spine, and like the first row in the cinema, you don't want to sit there for long. So you need to know what the vertical angle is at the first row, but you also see in the end the readability in minutes. I have to explain that. You have a vertical angle of your eyes, and if you have a circle of 360 degrees, you take 1 degree, it has 60 minutes, and your angle to read characters is 17 arc minutes, just under 1/3 of a degree, and then you can see like you see with glasses. If you go back to 1 arc minute, then you cannot notice the different things any longer. So if you're before a digital board with pixel pitch, you can calculate with that when you do not see that any longer. So this is how we work with that. You see also the cones here. If you can try these cones and work those out so you can really know, because the horizontal line is about 35 degrees before your muscles ache, and all those things. It's just ergonomic studies. You can take that with you. Next to that, for instance, there are more things like the baseline. It's very important sometimes to have them high enough so that the teacher do not look into the strong beams, and for instance, we make it smaller. So and then you can see if it's too small, the further rows cannot see it any longer. So this is how we design together with architects and discuss with architects when they have their very beautiful drawings on the table. We try to check these things out. I want to go to another hole. What have we done for this? What we have is asset management. I will change it in the admin, and you will probably be shocked because if it comes forward, okay. We have all red tabs at the moment, and we decided by this month to reset all the tabs to red, so to do, because we have imported from several sources all these data, and we still need to validate those data as well. So if for instance, this projector or any device that we have a projector status. You can rule it out if it's not applicable, but to do is red. If you take one, if you are everybody within a team takes something, it's in progress, and when it's done, then it's complete. And when it's green, then you know that the data is correct and it's completely filled. So we need another few months. It's a lot of work, but we already had it. We only have to narrow it down. So this is one thing that we have to do. Another thing is, okay, if we open it in devices, then the devices from this specific hole, is showing. It takes the time, but we have a lot of filters, so you can easily find it on its IP address, MAC address, whatever you want. You go to that process and you get your asset management. You get the information that you need, and the computers. We will do that together with the IT department because they are responsible for the assets over there. We build an API, and then we exchange these information. The next one is we have also built education spaces viewer, and that is the viewer that we have to show I will show yours, Campbell, soon, that we have to see the features of a certain classroom, know what you have there, This is for a public site, and the same one in detail page, those are for the AV team, so you can see all the stuff for you. It's all behind raw access database, so it's even encrypted, etc. It's not possible for others to go there. Just to, this one is Strathclyde, and no, I'm hoping that you are still glad with it. But so this is a complete catalog of all the spaces, and it's have a link to your scheduling department, so that both the schedulers and the teachers can see up front what sort of space do I have, and does my pedagogy fit with that environment. The last one, and this is more a message to all of us. Let's work on it and start small to become climate neutral. I'm not sure if 2030 is feasible, but if we work on it and we do it together and we can help each other out, compare it, and you see, you will be shocked of the number of the carbon footprint. And footprint is a very complex story that a lot of PhD are working on it, and I probably think that you had your own officers who really work with that. But if you ask what is the footprint of our AV systems, the response stay blank. So we can help them to give some information. And although we know it's not that accurate, it's probably 20% off, but that means it's 80% right. And then is the next step. And with these numbers, we can ask the market, please help us. And we will not, I think that we will not choose, this is one watt less than the other company. We still choose our components as a part of a complete system, and not just for the boxes. So this would be my message. Now you are aware, you cannot forget it. We need to do it together. So this is my talk. Thank you.